Now, in the buildings, in the walls or columns are flexible, the motion of the roof is different from that of the ground. If you imagine a building whose roof is supported on columns. Coming back to analogy of yourself on the bus, when the bus suddenly starts, you are thrown backward as if someone has applied a force on the upper body. Similarly, when the ground moves, even the building is thrown backwards and the roof experiences a force called inertia force. If the roof has a mass m and experiences an acceleration a, and its direction is opposite to that of the acceleration, thus clearly from the example we can say that more mass means higher inertia force. Therefore, lighter buildings sustain the earthquake shaking better. Now, horizontal and vertical shaking. Earthquake causes shaking of the ground in all the directions. Along the two horizontal directions, say x and y, and the vertical direction z. Also during earthquake, the ground shakes randomly both back and forth, that is negative and positive, negative this and negative, this one positive, in each of the directions x, y and z. So all structures are primarily designed to carry gravity load, that is they are designed for a force equal to the mass m. These include mass due to its own weight and superimposed loads times acceleration. So these gravity force due to g is called gravity mass. So this gravity mass acting on z direction is sufficient to resist the shaking along z to force exerted due to shaking along z direction. But for x direction and y direction, we need to design the building to resist the seismic force along x and y directions, that is basically the horizontal directions. So, effect flow of inertia forces to foundation. Under horizontal shaking of the ground, horizontal inertia forces are generated at the levels of mass of the structure. These lateral inertia forces are transferred by the floor slab to the wall or column, through the wall and column to the foundation, and then to the soil underneath below. So each of these structures or members, which are floor slab, wall or column and foundation, and the connection between these must be designed safely so that they can transfer the load of this inertia force through them safely. So now the time for assignments. The following question you should do as an assignment and need to submit before coming to the class. Thank you.